Alright, so in this question, the first thing we need to do is find the solution, and we can do that without graphing. The graphing just tends to reinforce that. Alright, so let's go over here and work it out, and then I'll show you how this works. Alright, so we start with this set of equations here, 5x minus y equals 9, and then 2x plus 3y equals 24. What we want here is for one of these coefficients to cancel out. So if we multiply the first equation up here by 3, we'll see that we can make this happen. Because I have 3y here, and this is negative y. If I can make that negative 3y, they're equal and opposite. So I'm going to rewrite and have 15x minus 3y equals 27. And then I leave my second equation unchanged. And so we come down and we get 17x equals 51. And we divide by 17, so x is equal to 3. And then from that we can go find y. So you could say, use the first equation and plug 3 in for x. So 5 times 3 is 15 minus y equals 9. So take away 15. And we get negative y is negative 6. And so divide by negative 1. And we find out that y is 6. Alright, so that's the solution for this system of equations. Alright, so now it wants us to graph. So let's go back and talk about the graph. Alright, so the way that I teach by this point in math class is to go to the slope-intercept form. By the time you get to this level of algebra, and if any of you ever have to go on to more math after this, you'll find this is the fastest way. Alright, so we divide everything by negative 1 there, and we get y equals positive 5x minus 9. So I just rewrote this in terms of y by itself. So subtract 5x from both sides and then divide by negative 1. And the reason we do that is because that tells us the slope, and that tells us the y-intercept. Alright, now on the other side, do the same thing. And here we get divide by 3 everywhere, and so we get y equals negative 2/3 x plus 8. Alright, now there's another way to graph this. Just really quickly I'll demonstrate here how you might do this. You can use the Intercepts method, which says if x equals 0, that basically goes away. So that means 3y equals 24. Y has to be 8. Right? So if x is 0, y equals 8. And then the other one says, now what if y is 0? If y is 0, we scratch that out. 2x equals 24. That means x has to be 12. Alright, so that's another way. You plot those 2 points and connect the dots. Now you'll see one of the problems with that method is over here in this equation. If y equals 0, then x is equal to a fraction. X is equal to 9/5 in this case. And that's one reason I kind of stop advocating that method as we go forward in math. Is because, especially with MyMathLab, you can't graph 9/5. Alright, so that's part of the holdback from doing that. So anyway, let's go graph these lines. So we have 5x minus 9 and negative 2/3 x plus 8. So 5x minus 9 means that the graph starts, the minus 9 tells you the y-intercept, and then the slope of 5 means go up 1, 2, 3, 4, 5, and over 1. And so that's the first line. And the second line is negative 2/3 x plus 8. So we cross the y-axis at 8, and we go down 2 and over 3. So click the line again. So click the line again so it turns that one from being yellow to blue. Now we're doing a second line. So we click 8. And now we go down 2 and to the right 3. And so now we can actually test. We saw when we worked this out earlier, the solution down here was 3, 6. That's the point in space where these two lines cross. And in fact, we see that that is true. When x equals 3, 1, 2, 3, 4, 5, 6, and y is equal to 6, these two lines cross. So it's a graphical representation of the solution set. And so that's how you do those two lines, using slope and intercept. The slope is that number there, and the y-intercept is the number. So start at the y-intercept and then rise and run according to the slope.